All right, the name of this section is Measures of Central Tendency. So this is about the middle, like knowing about the middle. And we have different ways of doing that, the mean, the median, and the mode. And this is all about like where the numbers are heading and how comparing with numbers and all that kind of stuff. So especially, there's two ways to look at it, like being above average or below average. If you're talking about like making money, like earning money, hey, you want to be above average because that means you're making more than people. But if you're talking about like the number of mistakes that you make in your job or whatever like that, you want to be below average, right? Because you want to make less mistakes, but you want to make more money. So mean, median, and mode is part of this. And then this is a huge concept in statistics, and we'll talk about this in intro to statistics too. Population versus sample. A population is the whole thing, all of it. A sample is a part of the population. So my example right here is school. Right? If everybody in the school, like the Hillsborough High School, has a population, right? And if you want to ask them a survey question, you don't necessarily can talk to every single person in the school. Well, through email and Google Forms, I guess you can now. But in the olden days, you wouldn't necessarily want to talk to every single person. You want to just talk to a sample of people. Also, the problem with sending out a Google form and surveying is the fact that not everybody responds, and only the people that respond, they could skew the data. So it would be better to like force every fifth person to answer the questions, so you can get a sample, a good sample. So what makes a good sample? And a sample is a subset of the population, and the population is the whole school. The mean is the average, right? So population mean is the Greek letter alphabet mu. And the way you make that is you don't make a U, you actually make a little hook thing on the front here. So that's mu. And then the sample mean, we call this X bar. That's why you say that. So we say X bar because we put a bar over the top of it. So anytime you see this, it means the mean of the whole population, and then the X bar is the mean of the sample. And this is, like I said, a huge concept in statistics. We basically want to know about the means of samples so that we can project onto and make inferences about the population mean of the overall thing. And again, this is a huge concept in statistics, and we'll talk about it over and over and on all through intro to stats. But this is kind of the first time you're hearing it. So population, its mean is mu, a sample mean is X bar. Example 1, find the population mean of the quiz scores. Well, I'm also going to review what we did yesterday. First of all, you have 10, 9, 8, 7, 6. So like the kids took some quizzes and 2 people got 10s. So I'm guessing like 10 out of 10. 5 people got 9s, etc., etc. So is this qualitative data or quantitative data? That's right, it has to do with numbers, so it's quantitative data. So it's quantitative data. Frequency, and then you can always go to the next column here, and that's the relative frequency. This is review, and you compare that to the total. So we need to know how many people there were. So there's 7 and 3 more, 7 and 3 more, 11, 14, 15, 17. So the relative frequency would be 2 out of 17. I did add that right, 7, 11, 14, 15, 17. So 5 out of 17, 4 out of 17, 3 out of 17, 2 out of 17, 1 out of 17. So the relative frequency would be like the probabilities of finding these people. So if I just went out and grabbed a person out of this group, there'd be 4 chances out of 17 that they got an 8 on the quiz. That's the chances of finding that. So relative frequency is dividing the total by the frequency, or the frequency by the total. So the total here was 17 students or whatever. So this this problem on the next page has the different has the gaps here, right? So this we have to pick numbers in between, right? We have to say like 9.5. But for this one here, I know exactly how many people got it. So 10, 2 people got 10s, so that's 10 points times 2, so that's 20 total points towards finding out the average of their score of the kids. Plus 5 people got 9s, plus 8s. 4 people got 8s, plus 3 people got 7s, plus 2 people got 6s, plus 1 person got a 5, divided by 17, and that would be the average. So we're going to get this out here and put it in the calculator. So it would be parentheses 20, because that's 20, 45, 32, 21, 12, and 5. If you don't, you could type it in exactly like this if you wanted to, and then divided by 17. All right, so the average of this, and this is a population, it's the whole thing. So we can say that mu is equal to 7.941. All right. So that's how you do that. So we got to put, now you could type 10 plus 10 and then plus 9 plus 9 plus 9, plus, 5 of those, plus 8 plus 8, but it's faster to multiply 4 8s instead of like, typing it in all the times. Again, this is a distribution, right? So it's like the first section of the chapter, frequency distribution. So these are all the scores, and this is how they're distributed. And the numbers tell you how many happen. So it's called a frequency distribution. And that was the first section, frequency distributions. All right, now we're going to find the average here. Oh, guess what? This is the same data, right? This plus this plus this is 17. It's the same data, but see what I did? I said 9 and 10 is 7, and that's 7, and then these together is 3. So we can even compare, like, just to show you that these averages could be pretty close. So that means 9.5 is the mid on that, and 7 kids got that. And then the mid on this is 7.5. And 7 kids got that. And then the mid on this is 6.5. Or 5.5. And 3 got that, divided by 17. Okay, so this answer should be fairly close. Just to show you that it is, and I'm not just messing around here. So it's 9.5 times 7 plus 7.5 times 7 plus 5.5 times 3 divided by 17. Ooh, see how close it is? So the other one was 7.941, and this is 7.971. So mu is equal to 7.971. So even though I didn't know the exact numbers, because I did this number in between the ranges there, I was able to get an answer close enough, right? And and essentially you would say, hey guys, the average score was about an 8. Okay, so if you got 8, above 8, a 9 and 10, you're above average, right? If you got a 7, 6, or 5, you're below average, right? If you got 8, you're like right at the average. That's what you would broadcast back to the troops. You've been doing mean, median, and mode for a long time. The median is the middle number, and basically you just have to have the data in order. So the data in order would be the median. Extreme values can inflate or deflate the mean, so using the median is a good idea. So if you have really, really big extremes or really small extremes, if you use the middle, then that would be most frequent. The mode is the most frequent, and you can have two modes, then you would call it bimodal, but basically it's the number that shows up the most. So if we go back to our data here with the quizzes, 9 shows up 5 times, so 9 would be the mode. 9's the mode, but the average is basically an 8. That's what you would say about this data here. So 9 is the mode. The middle number would be, well, the way you do that is you would go 8, 1, 8. Okay, so 8 plus 1 plus 8 is 17. So if you go 8 from the bottom or 8 from the top, that 9th number would be the middle. That would be the middle number. So if you go 1, 2, 3, 4, 5, 6, 7, and then 8 would be an 8, and so it'd be another 8, right? Because there's 4 8s. So 8 would be the median. Whoops. That's the average, and then the mode was a 9 for this data right here. And so what am I talking about? The middle number. So maybe it'd be easier if you'd see, like, okay, you wrote 10, comma 10, comma 9, comma 9, comma 9, 9, 9, right? So there's 1, 2, 3, 4, 5, 6, 7, right? And then it's 8, 8, 8, 8, and then it's 7, 7, 7, and then it's 6, 6, and then it's 5, right? So those are all the numbers. So you could go 1, 2, 3, 4, 5, 6, 7, 8, right? And then you go this way, 1, 2, 3, 4, 5, 6, 7, 8, right? So you can clearly see that the middle number is 8. All right, so that's how I'm getting the median there. All right, and that's it. That's the lesson. And here are the problems right here. So the first problem is about just finding an average, and it's in all the things related to averages, finding medians, finding modes, these tables where you have the, you're going to use the middle number, and then some graphs. Don't know why there's a $sign there. Okay, so I think this is all pretty straightforward. So, peace out.